Hello, everybody. Welcome to the Kubefirst live stream. I'm super excited to be here. I don't know if you've seen, I missed the last two. I was off on vacation. I was in India. That was awesome. But let's be honest. I'm not saying that because John and Jared are here, but like I missed those live stream. I missed everything we do at Kubesharp. So super happy to be back here and be there for that, which I think really great live stream we're going to have for you today. So today we're going to talk about HashiCorp Vault. We're going to show you how the awesomeness of that platform and how we use it within Kubefirst. But before we jump in any topic, we need to introduce the people that are on the live stream. So John and Jared, would you like to introduce yourself?
Yeah, hey, I'm John, Fred. We missed you for a few weeks while you were gallivanting the world, but it's great to have you back. I'm one of the co-founders of Kubefirst, and yeah, we're excited to show some HashiCorp Vault. We've been HashiCorp Vault fans forever. It's been a part of the Kubefirst platform for a really long time, and continues to impress us with the capabilities that it provides. Jared, do you want to introduce yourself?
Yep. Hello, and I'm Jared. I'm the other co-founder of Kubefirst, and we're going to talk about some HashiCorp Vault.
Yeah.
That's awesome. That's awesome. So let's start with the agenda. So pretty simple today. We have a really nice agenda, though. For those of you that are new to Kubefirst, we're going to introduce you quickly to what the heck is Kubefirst, because that's more interesting to know the platform before we start to do some demos and talk a little more about it. As I said before, we're going to talk about HashiCorp Vault, the open source project. So if you're not familiar with it, you can go on vaultproject.io. Great website, a lot of documentation. It's open source, but do not worry. Actually, don't go check that website right now. Stay with us. And don't worry, John's going to talk a little more about Vault and what it is and what's the benefit of using that great technology. But also, Jared's going to demo us how it's working and what you can do with it. And as I said, how we use it within Kubefirst. And lastly, we have a pretty cool announcement for you related to Sivo. So with that said, what is Kubefirst? It's an open source platform. It's, I like to say, and I know maybe not everybody agree with me, but I like to say that Kubernetes it's an awesome and powerful platform, but it's not always easy to get started. And even if you know the platform, it's not always easy to get your way within that platform. And it makes sense because it can manage so many things. It's a powerful tool. So it's not always easy to use. And this is what we try to do with Kubefirst. We try to make it easy for you to deploy your Kubernetes cluster. So we are Kubefirst. It's an instant GitOps platform, and it's open source and it's free. And what we do is with a couple of commands on a command line, we offer you a CLI that really helps you to deploy your Kubernetes cluster more easily and faster. And how we do that, as you can see in the diagram, we use some of the greatest CNCF tool, cloud native tool that we incorporate within Kubefirst. So we basically tackle all the complexity to make it easy for you, again, to deploy your cluster. Really great tool. And in the end, once you start to use Kubefirst and you use Kubefirst to deploy your cluster, you end up with a GitOps repo. That is where all the magic happens. So after you deploy your cluster, you have that repository and it's basically yours. So we pre-install some of the stuff, we put everything together, we basically kickstart you with a powerful Kubernetes cluster that have most of the tools that you need to be successful. And after that, it's all yours. You do whatever you need to do with your cluster. You deploy your own application, you customize whatever you need to customize. So that's the beauty of using those kind of tools that are open source, that are part of the CNCF landscape, but it also the power behind an open source project like Kubefirst. So quick introduction. I don't know, John, Jared, if you want to add anything to what I've said.
No, I think you nailed it. Yeah, it's all open source. The platform that you end up with is powered exclusively by the GitOps repository that we create for you, and then we allow you to host it. So if some of our opinions aren't in alignment with your project needs, all you have to do is pull request to get rid of our tools and add your tools, or extend the platform to your organization's requirements. It's a very GitOps centric offering, all free and open source, like Fred was saying. So,
and even better to that, you can even do a pull request to the Kubefirst repository to add any tools that you find would be useful for people using Kubefirst. And what's great is that you're not tied to one platform either. So you can deploy on AWS using GitHub as your main source for Git repository, but you can also do the same with GitLab. And maybe by the end of the live stream, we're going to add a new platform to the one that we're offering with Kubefirst. So with that said, I'm leaving the mic to John, who will talk to you about everything and anything HashiCorp Vault.
Yeah, just a quick overview of HashiCorp Vault. Vault is one of these rare open source technologies that is just jam-packed with capability, all on their open source free tier. So now Vault has an enterprise ecosystem. They have a SaaS-oriented enterprise where, if you ever wanted to offload the burden of managing your own self-managed HashiCorp Vault, you could leverage their SaaS ecosystem. You would obviously have to pay them for that. But if you're running a Kubernetes, particularly a Kubernetes cloud native oriented platform, HashiCorp Vault fits the bill for a lot of different problems that you're going to have. A lot of organizations, especially when you're a new startup, when you're starting out on a new project, you kind of think about secrets management in a simplistic way. You think to yourself, well, I have a backend Postgres database or something, and my application needs to be able to provide that password to the database to connect so that my application runs. And that's kind of the mental model that a lot of people have in terms of like what secrets management is. It's like you have an app, the app needs to connect to a backend, or you have a CI pipeline and it needs to be able to publish to Docker Hub or whatever it might be. And you need a place for that secret to be safe. And that's very true that is a use case of a secrets manager. But there are a whole bunch of other use cases for a tool like HashiCorp Vault. HashiCorp Vault allows you to not only store your static secrets in sort of like a key value store, but it also provides engines to allow you to have ephemeral secrets that automatically rotate on a cron. You can leverage HashiCorp Vault for your PKI infrastructure. You can use it, and we're going to demo today how the Kubefirst platform uses it as an identity provider for your platform. So, a lot of organizations will have like a G Suite or an Okta, but it's managed by an IT team. And if you want to have an IDP that's specific for your engineering group and be able to extend that IDP with an OIDC provider that's enabled throughout that platform, you have this really powerful capability to manage your groups and your people and your roles and your access to your platform tools in a very straightforward way. Because it's HashiCorp that built Vault, it works very, very well with HashiCorp's Terraform. All of our Vault configurations are powered by Terraform, and we're gonna look at what that looks like a little bit. We actually have the Terraform automated with Atlantis, so it's a really complete, comprehensive story for Vault management. We use it for because of the OIDC provider. We leverage that as a single sign-on mechanism, so your engineers that are developers or your engineers that are admins can just log into Vault, and they automatically have access, the right levels of access to all of these different platform tools that are part of the Kubefirst platform. And like Fred was saying earlier, HashiCorp Vault, everything that you're going to see today is part of their free and open source offering. And it's a very scalable and recoverable solution that we're putting forward on the Kubefirst platform. So Jared today is going to demo a little bit of how we have HashiCorp Vault wired into the Kubefirst platform and show off some of these cool features.
And that's pretty awesome to me because, I'm no security expert, but security is so important. And you know what? When I talk to developer or people managing system about, and I ask them, like, is security is important for you? Like everybody says yes, of course it's important. But when I ask people, what are you doing to make your system more secure? What are you doing to make your deployment or your cloud application more secure? Most people are like, I use SSL and, I'm being careful with my secrets. So, you need to go the extra mile when it comes to security because your project has one chance to be respectful with the information of your users and be sure that it's secure for your users. And I feel like HashiCorp Vault is basically one of those tools that you need to implement right away within your solution. So super happy to have us talking about it and Jared demoing. But even before, I'll leave the mic to you because as you probably know right now, I love to talk. I want to remember, yeah, they're laughing. There's a reason for that. But I want to remember people that are listening to us that if you have any question, if you have any comments, ask them in the live chat, whether you're watching this on Twitter, on LinkedIn, on YouTube. We see your comments and we may not address them right away, but at least I'm going to be there and I'm going to ensure that we answer your question. And with that said, I want to return hello to Bakary, who is watching us on YouTube. So hello, Bakary. Nice to not see you here, but to see you here in the live stream. So on that note, I'm leaving the stage to Jared, who will demo us and explain a little more about HashiCorp and all the awesome thing around it.
Awesome. Thank you, Fred. So this is what the vault will look like when you're signed in currently signed in with the bot user that we provision with the platform. We need some mechanism to be able to get you into Vault initially and allow you to start adding your own users and access the secrets that are there across the platform. So currently signed in with this user KBot. KBot's an example user, and where that lives is going to be in Vault. There's a secrets backend called the users, and this is going to have some initial temporary passwords for the users until you reset your password. And if we go under the Access tab, we'll get to see all of the authentication methods that we currently have in use. The one in question for this KBot user is UserPass, so I'll click into there. And these are the two users that Vault is aware of right now. Let's see.
KBot came out of the box. That JDeets user was one that I onboarded onto the platform just to test things out prior to the demo. But Jared, if you wouldn't mind switching over to the GitOps repository and sort of demonstrate what a user onboarding looks like through Terraform to get a new user onto the IDP in Vault.
Yeah. So at the end of the platform installation, you're going to have this new GitOps repository. Everything that we provision for you is created in Terraform infrastructure as code so that there's a nice trail of what we've done. We have our Terraform automated with Atlantis as well, which is an extra thing we'll see here momentarily. But we have this Terraform folder with the users directory, and then we have admins and developers. So I'm going to drop into the admins folder or file here, rather, in the folder file in users. And take this module block that we leave here for you to see what it would look like to add a new user. And real quick, but if John has anything to say, he can chime in while I'm typing.
Yeah, no, I guess just to fill the void in the air while he's typing through this, There is both a admin's TF as well as a developer's TF file. Those two files represent the example set for how to add an admin to the Kubefirst platform or how to add a developer to the Kubefirst platform. And the concept of a developer and an admin on the Kubefirst platform, it's a little bit of a simple setup. They do start out with reasonable defaults for developers and reasonable defaults for admins, but you can basically take that pattern that we put forward in Terraform and extend it to as many groups and as many roles as you need from there. So here we can see Jared it has put forward a pull request. Let me hop over there and give you an approval real quick. But if you could talk through that plan for me, Jared.
Yeah, so just by opening the pull request against the GitOps repository, there's a webhook that we create for you that is used to let Atlantis know that something has changed. And each of the folders within the Terraform directory structure, we refer to as an entry point loosely, but those entry points are all watched. And if changes happen to any TF files in there, then Atlantis will automatically run this for you. It's just a nice way to provide an automation layer over running Terraform on your local host. Sometimes when you do, you'll be halfway through a change and apply will fail, and then you never get back around to finishing that apply, and then another developer tries to interact with the state store and everything's left a mess. So Atlantis is a great tool to help alleviate some of those pain points. And what it'll do here is as soon as I open the pull request, Atlantis, I can scroll to the bottom really quick and show these jobs. If we show all checks, we can see that it ran a plan and it ran it against the Terraform users directory. And then the changes that it wants to make here are going to be starting under this line. And it's going to add Jared Edwards to a GitHub team in this GitHub organization called your DNSIO. And then it's going to add these resources to Vault to let it know about me as a human user. So I'm going to go down here, and because John gave me an approval, I'm going to type Atlantis apply as a comment and hit enter. And then you'll see this job will kick off. This webhook was fired again. So Atlantis now knows that it's going to run apply to actually create those resources we saw in the plan. And that looks like that was successful. So it goes ahead and closes the branch for you and cleans everything up, closes the pull request. And now when I drop back into Vault, if I just go to the user pass auth method, I have this new user, J Edwards, that I just created. So what I'm going to do is we store the initial password for the user in the secrets KV store called users. Only the root level people, so the KBot user and the root token, give you access to this on the Kubefirst platform. We don't want people and just anyone that has access to Vault to be able to see people's initial passwords. But if I drop in here and grab that value, I can go ahead and sign out. And make sure I'm using the username method here and add my new username I created and my temporary password. And I'm into Vault as an admin. So now that we've created this user, the first thing I'm going to want to do is update my password. So to do that, we're going to drop into the access tab again and drop into the user pass auth method that we were talking about earlier. If I just simply click on my username, there's this edit user button. And by clicking edit user, I can now set my new password. So I'll do that really quick. And I don't think I typed that right. So let me try again. All right. And we're going to hit save. And now I'm going to sign out of Vault again because that initial password is no longer valid. Oh, I think I did it backwards again.
Passwords are not easy.
Whew. I know, and I mixed up the two words in my head twice.
But Jared, that worries me a little bit. Like, anybody can just go on Vault and change password? Like, please enlighten me. Like, what are the rules around that? Like, who can change the password?
No, there are actually, Vault has a whole bunch of ACL policies, which we're going to get into in a little bit more depth here in just a few minutes. But essentially the way that works is only the username, the identity ID associated with the user that we created for you is allowed to update the passwords for the individual users in that user pass auth method.
Right. Plus, administrators, as long as you keep our default ACL rules, administrators will be able to reset other people's passwords. So if somebody forgot their password and they can't log in to reset their own password, an admin will be able to reset it on their behalf as well.
Yeah, thank you.
So Jared, at this point, can we switch over to, let's see, you changed your password. Now that you're logged in with yourself, with your new password, can you show off the single sign-on aspect of how we're leveraging the IDP throughout the platform?
Yeah, so we have this Kubefirst console page, as we refer to it, that is where you're going to land at the end of the installation. And now that once you sign in with your user, you'll be able to, oh, that was GitHub. That was a terrible tile to click. Let me go back to there. So I can click Vault. I'm already signed into Vault, so that's a good one. But my user is aware, or Vault is aware of my user and allows me access. I can visit Argo CD, and it'll be the same story. Ooh. I made one error on my pull request. That's
who approved that pull request, Jared? Jeez.
Well, John, we don't need to talk about that. So, this is actually good to do, so I'll slow down here. The problem is that I didn't associate my new user with that client application. So if we go back to the Terraform here, this line needs to be changed. I needed to add my user to this, and admin 1. This is Jared Edwards. So let's open another pull request.
And I'll actually review it for you.
No worries. That'll be pull 5. All right, look at Atlantis go. It's a quick fix and actually an issue that we have open currently, and now I have extra motivation to go ahead and fix. We scroll up here, we can check out the plan that Atlantis ran for us, and it just sees that we're adding a new membership of my user ID to the admins group. So just back on track, I'll Atlantis apply that.
But for me, that's a good example of the power of like GitOps. You know, everything is on Git. It's easy to have history. It's easier to find what's the issue compared to like, hey, there's just someone random went on the server and did something and nobody knows about. Now everything is transparent. It's clear. So good job on making that mistake. I think it was nice to showcase that.
And shows that any old person can't get into your platform tools as well. You have to be a part of the admin group or the developer group in order to get access to these tools. So I agree, Fred. This was a very solid plan.
A happy accident. Just clicking on the user icon here in the Argo CD UI, you can see that this was the user I just onboarded. Not anything too fancy there, but this is the story across the board for the tools. So I'll drop into Argo as well and show my user, which says John at Kubefirst. That's odd. So don't know how to explain that away, but I believe it's because this is log out.
Now you're Jared. All right.
I don't know what that was, but okay. Well, here we are.
You had a cached session, so it didn't re-authenticate until you logged out.
Perfect. Well, so where are we going from here, John?
So from here, where are we going to go? Let's go to single sign-on throughout the platform tools. Let's go to the ACL in HashiCorp Vault, and let's also look at it in the context of how we have it configured in Terraform.
All right. So let me open the GitOps repository again. We're going to go back to that Terraform entry point and into the Vault entry point, not Terraform. I guess it's kind of the same, but we can take a look at our policies here, and we'll scroll down obnoxiously all the way to the developer policy. And I'm just going to call out for an example. So developers have access to only the paths, secret development and secret staging so far here. And when we look at the policy that Terraform created for us, it resonates those same top policies. The rest of them all line up as well, though.
Right on. Yeah. And just to sort of call that out for our end users, like every organization is going to run a little bit different in terms of what you want your development team to have access to. But generally speaking, there's going to be some stuff that you want your developers to have access to, and there's going to be other stuff that you only want your administrators to have access to. The way we have implemented our static secrets access for these two different human roles of admins and developers is that we have these two different ACL lists where you can basically just say what secrets, and you can wildcard whatever you want, but you can designate which secrets are okay to be readable, viewable, editable, deletable, etc. On a role-by-role basis, and then you can apply that ACL to your various groups. So, we start you out with a developer and admin group. If you wanted to extend that to include a QA group or a read-only group or whatever you wanted, you'd be able to define those tight controls over your static secrets and who can see them. And if you have different secrets for development than you have production, and you want to keep your production environments under wraps, you can do that and make them only accessible to your admins, but allow your developers to have a very rich, full administrative permission set for the development environment with just a tiny bit of flat ACL rules in Terraform that you apply the same way that we apply everything in Terraform.
And we had a question from Ulia, and I hope I said your name correctly. And I think you just answers how it's working for new users, because you demo how to modify the access or change the password of actual users. But we also apply this with policies and Terraforms, right?
That's exactly right. Yep.
Thanks for the question, Julia.
So I think that pretty much covers what we wanted to show from an ACL standpoint. Like it sounds complex, an access control list. Really, we're just talking about some simple rules in Terraform that we apply to Vault. They show up in Vault the same way that they are defined in Terraform. It's a pretty straightforward story. As you continue to use Vault and you add more secrets to your ecosystem, maybe you're adding a Datadog API key, maybe you're adding a token to have write access to your Docker Hub repository or whatever it might be for your organization that you need to keep a secret safe in. You can define very easily what those ACL rules are for on a group by group basis and tightly control who has access to what.
Just one last thing on policies I'll throw in there as well. Vault's really, the policy, the access control list feature is very configurable. So it does allow you to layer multiple policies on people very easily. And right now ours are very simple out of the box. So you get an admins and a developers, but you can create your own policies and map them on top of the users to be able to give them additional access or restrict access, and really make sure that your teams are configured how you'd like.
Right on. So let's dive into some static secrets if we can. Let's maybe take a look at the developer metaphor secret and show a little bit about what that looks like in Vault as just a native Vault secret. And then let's perhaps look at the external secrets operator backend that we're leveraging to be able to get that secret out of Vault and into the Kubernetes cluster.
Sure. So let's start on the journey. We use, as John mentioned, just kind of a simple static secrets engine. It's a KV storage for key value pairs. We call it secret, and these are the ones that are on the platform. So as mentioned earlier, if you had created a developer role, they'd only be able to access the development and staging ones, but I'm in as admin, so I can see everything. What that allows us to do is getting back to putting secrets into Kubernetes. We can go to the development namespace here and look at the Metaphor app. And these are the two secrets that we want Metaphor to have. And by putting these values in Vault, we then create an external secret, which is a CRD that comes from the external secrets operator. And by adding that to the cluster and letting it know about Metaphor secrets, it'll automatically pull this value out and create a Kubernetes secret from that CRD resource. So to look at that visually, the Metaphor development application has this external secret. and we can look at the live the manifest here if we want. But essentially, it's accessing Vault and saying that at the development metaphor path, there's these two values, and metaphor needs them. So it creates the native Kubernetes secret here with those two values that Vault's able to ingest. And we have Vault ingesting those through, if we click on the desired manifest here, we can take a look, just through an env from a secret ref. So all of the keys are available to us. We just have the two coming in that are there, but tons of functionality with external secrets operator to do complex secret mapping. So
right on. Can you pull that up in terminal and like kubectl pull that secret so that we can see the native Kubernetes secret that was rendered from that external secret?
Yep. So if we do the native Kubernetes secret is this metaphor development secret here. And if we want to inspect that, let's do secret metaphor. If we want to look at this key, so I can already base64 decode it, but development secret 1 will line up with development secret 1. Those two values match. And should I make the secret change now?
Yeah, let's go ahead. We got it all shown. So
all right. So we're just going to change secret 1 to be new development secret 1. Really, really creative. And then if we come over here for a visual, we see this, it just pulsed there. So every 10 seconds, we have our external secrets set to check in with Vault to see if that value has been updated. And if it has, the external secrets operator is going to take the new value out of Vault and update this Kubernetes secret. So if we want to view that secret again here, we can do just that same get request, and we'll see that it now has new, that didn't work, new development secret. So that value is automatically updated. That's another great time to just call out that another feature that we really like about Vault is that it gives you version secrets. So if I wanted to go ahead and revert that and change it back, I can do a diff of the history to see who had made changes, or yeah, you can pull up the audit log if you'd like, but you can compare secrets across versions so that you can see what has changed if something does introduce a bug or somebody updated a password or something of that nature.
Awesome. Let's see. And we already, yeah, I guess at that point, we should probably just describe a little bit about the redundancy of both the version management as well as the backend store. So the way that the version management works native to Vault, the way that Jared's showing it to you here, is just that anytime anybody makes a change, there's a new version of the secret, and it keeps the old versions of the secret in a list of all the changes that have made in a history log of how many times that secret has changed. That's really no different than like what you would get out of your cloud provider's secrets engine, like SSM parameter store, for example. If you have versioning turned on, you'll get that same history. Now, in Vault, the way that we have it in AWS, we have the secrets backend in a AWS DynamoDB backend. The data at rest is encrypted with KMS, and the DynamoDB table itself is pre-configured with point-in-time recovery established. So in a circumstance where somebody that had full admin permission perhaps went through and wrote some new script that they were going to apply to your Vault cluster, they could technically just destroy a KV secret that you needed. And that would be problematic. You have the ability as a full admin to permanently destroy a secret in Vault. Now, if that was done accidentally, and now you're in a disaster recovery scenario, you need the ability to recover those secrets because you're investing your secrets into this HashiCorp Vault space. So in order to recover that, we have this really neat methodology because of the way that we're leveraging DynamoDB, where you can go to the point in time that was just before that disaster scenario happened. And then you can create a new DynamoDB table from that point in time. And then you can adopt that new DynamoDB from that point in time in Vault, as long as you're keeping your KMS key intact, you'll be able to continue to decrypt all of the secrets that are stored in that new version of your DynamoDB backend table, and you restore all of your secrets just like that, and Vault is able to fully recover. Now, you might wonder, in a disaster recovery scenario like that, what happens to your applications? Your applications are dependent on these secrets, and these secrets are in HashiCorp Vault. And as I just described, some admin went through and made a disastrous circumstance, and now Vault is down. It can't work, or the secret that the application required no longer exists, and there's no longer any history of it except in this DynamoDB backend. So Vault goes down, or you have some problem to tend to in Vault. What do you do about that? With our implementation of secrets management in Kubefirst, we never directly access HashiCorp Vault from any of our applications. We're leveraging this really cool tool called External Secrets Operator. External Secrets Operator runs in your Kubernetes cluster. You define a backend in Vault that you want external secrets to be able to access. Jared's showing us right here the Kubernetes Kubefirst backend. That's the backend that External Secrets Operator is going to be leveraging and verifying itself against in order to gain authenticated access to the secrets that are kept in Vault. So because we have this External Secrets Operator shim layer in between your application that needs a secret and Vault that houses the secret, there's this eventual consistency architecture where External Secrets Operator is always checking with Vault. Hey, do you have a new update for me? Hey, do you have a new update for me? And as long as Vault is up, if there's a new value, it'll pull that value down, turn it into a native Kubernetes secret for your application. So because your application is only dependent on a native Kubernetes secret, if Vault were to go down, your application never needed Vault in the first place. All your application needs is the secret that the last time Vault was up, External Secrets Operator was able to pull that secret into the namespace, establish a native Kubernetes secret, and your application can continue to run. So if your application pod were to restart and it needs a fresh pull of its secrets, it's not pulling those secrets from Vault, it's pulling those secrets directly from native Kubernetes. So you don't have that same real-time dependency on Vault that you would have if you were integrating directly with Vault through like a sidecar or something like that. So we think that that's a really cool methodology to be able to reduce the burden on your operations team of the requirement of keeping Vault up 24/7, 365. Obviously, Vault runs in a high availability mode, and it is very stable, but that doesn't mean that your administrators can't make mistakes. And if an admin makes a mistake and you're in a disastrous circumstance, you don't want your applications to be negatively impacted by that condition. You want to be able to give your ops team time to handle the problem and get Vault back up and off the ground. And only once it's back and up off the ground will External Secrets check back in and say, aha, Vault's here. Let me see if I have any new secrets to pull in. If it does, it'll pull them in. And your applications were none the wiser. So it's a really nice posture to have from a disaster recovery standpoint, because you're buying in so heavily into a Vault secrets management paradigm. Yeah.
It's also nice to mention that if your developers are manipulating secrets in any of the namespace.
Oh, that's nice. I don't know who wrote that, but thank you.
That's perfect, Fred. If you do make manual changes to your native Kubernetes secrets, the External Secrets Operator will update and overwrite those. So it gives you a nice single source of truth for what the value in your Kubernetes ecosystem should be.
Yeah, that's a really good point. And a lot of times this question, this topic comes up in the Kubefirst platform, particularly really in any GitOps ecosystem. The question of like, when you have your application secrets in an ecosystem like Vault, like how do you have secrets for your application in a way where you can do GitOps and you can have the secrets leveraged by your application. But what do you do with the secret? Because the age-old wisdom says that you should not be keeping secrets in your Git repositories. Now, there's a couple camps on the right solution for that. And with good reason, there's some good options in the wild. One option that some folks go with is the concept of sealed secrets. Sealed secrets is a methodology where you can proactively encrypt on your local the secret and commit that encrypted secret to Git. But what that means is that you need to sort of distribute a decryption key to all of your developers. Maybe you don't want to do that. In my opinion, I don't think that's the best pattern for being able to keep leaks low and the ability to rotate high. With HashiCorp Vault, because we're leveraging external secrets operator, we're able to only reference the reference to the secret in GitOps in a way that is repeatable. And the construction of the secrets that are housed in Vault is fully integrated with Terraform. So if you need to generate random secrets for your databases, you need to generate random passwords for your users, whatever it might be, it's very Terraform capable to be able to establish those secrets in an IAC way and then leverage those secrets in a GitOps oriented way. So really cool story there. There's a whole bunch of other stuff in HashiCorp Vault 2 that you should know about. It's not stuff that we're going to demo today, but Vault has this whole world of just really great free open source secrets management stuff. Things like being able to create ephemeral secrets that rotate every 30 seconds or whatever you need them to be. Things like leveraging HashiCorp Vault to be able to access your cloud in the terminal or in your browser's console. PKI infrastructure for the secrets that you're generating for TLS or for MTLS. If you have a service mesh and you just constantly need to be creating secrets for that MTLS, HashiCorp Vault has a great solution there. Cloud access leasing, all kinds of stuff. Check out HashiCorp Vault. They're incredible. Their open source offering is truly one of the best open source offerings that I've ever seen in the cloud native landscape. So really worth a good look. And if you want to see how it works in a working form, I think the Kubefirst platform is a really great demonstration ground for checking that out.
That is pretty cool stuff. Thanks a lot. And we briefly mentioned Argo CD. So just a quick reminder that not too long ago we did a live stream, or those two guys with me did a live stream with Kelly. She's awesome. She replaced me when I was away. So the recording is available on the Cube Shop YouTube channel, but here's a direct link. You probably want to take a little bit of your time to watch that really nice recording. So if you want to replicate what you've seen, you can do it at home without the help of your parents. So there's two ways to do that. You can go on kubefirst.io/download. You're going to have the instruction. You can also go directly on GitHub. So it's github.com. Its organization is Kubefirst, and the project is Kubefirst because we like being original. So Kubefirst/Kubefirst. And obviously, there's the docs where all the magic happen, where you should find all the information that you want to make it happen. And as you can see on the screen with a small code snippet, actually small CLI comment. So for macOS users, probably the most straightforward. You are probably using Homebrew. If you're not, what are you doing? That's one of the nice open source tools out there. But you can just do brew install Kubefirst or brew install Kubefirst/tool/Kubefirst. You need to configure your GitHub token if you use it with AWS and GitHub, and it's also pretty straightforward. So everything is on the documentation, so you can find the information there. You need to init your Kubefirst with, again, some configuration to be sure that everything is going to work magically right after, and Kubefirst cluster install, and this is where the magic happens. You're going to be able to have a new Kubernetes cluster with all the tools that we quickly shown you at the beginning, including HashiCorp Vault. So pretty easy to use, pretty straightforward. You need to try it. And I'm going to remember everyone on the live stream, and I'm going to check if you try it. Actually, there's no way for me to do that. But if you try it, if you have any feedback, we are always open to feedback. And if you see anything, hopefully everything's going to be awesome and amazing, and you're going to see star rainbows and puppies or cats. But if there is something happening, please create an issue on GitHub, or you can also join our Slack community and come talk to us, share your feedback. We are there for you. We are there. We are listening. So we have an announcement that is not really totally a new announcement anymore, because we were actually, John, were speaking at Civo Navigate last week, 2 weeks ago. I kind of like lost track of time.
Yeah, believe it or not, it was just last week.
It was last week, so he did an amazing job, talk about a lot of great stuff. He did. He spoke twice, like he gave 2 talks. So he just unleashed the what I call the Jits or the Jung beast mode. And so we announced that Kubefirst is going to support Civo. So remember the diagram that I shown you before with AWS, and really, really soon. So we are finalizing some tests and just ensuring that like the quality of the Civo integration is on par with what we want to do and what we want to give to the users. But you're going to be able to deploy your cluster on Civo, and that's pretty amazing because Civo, it's a cloud platform out there. And what is great is that it's a little more simpler to use than, I don't know, some other cloud platform out there. It's way more straightforward. It's also, you have no surprise when it comes to the pricing with Civo. So if you want to deploy your project there, you're going to be able to do that easily with Kubefirst. So
yeah, we're super excited about the Civo platform that we're getting ready to release now. The speed with which you can have a Kubefirst platform in a cloud environment on the Civo cloud is just a really exceptional experience. We've seen it as quick as 6 minutes from being in a completely empty Civo cloud to having basically everything that you saw today in AWS. We'll have all those same features and functionalities working in the Civo cloud. Like Fred was saying, it's from a Terraform standpoint, we're talking a lot less resources in Civo than we have in AWS. And AWS, no matter what the Kubefirst platform version is that you're installing, you won't need very much. We're always going to be provisioning from scratch. So if you have nothing and you don't want to be bothered with, how to set up a VPC, how to set up your subnets, how to set up your EKS cluster or whatever, we're always building out that foundational infrastructure for you. But in AWS, we're talking about like 60 some resources that are managed in Terraform in order to establish that foundation for your Kubernetes ecosystem. In Civo, we're talking 3. It's a very straightforward Terraform story. So
we're talking 3.
Yeah, I mean it's a light footprint. It's super frictionless. Now, a lot of organizations, a lot of new startups might be thinking, well, these new clouds, something like Civo, is it right for my organization? Can I scale to what I need to scale to be an enterprise company on Civo? First of all, I think the answer is yes, as long as you're buying into Kubernetes. But even if you're worried, and I appreciate that concern, because of the Kubefirst platform being that equalizer across clouds, you can have a Civo cloud and take advantage of the low costs and take advantage of the simpler cloud footprint. And then if you ever find that you need to outgrow the the Civo Cloud, just install a new Kubefirst platform over in AWS, and then you have everything AWS has at your disposal as well. So I don't know. We're super excited about the Civo story. Really excited to release that and start getting feedback from the user community. I'm sure that everybody's going to find it to be a very lightweight, very fast, very frictionless experience. And we have done a whole bunch of user experience care on the Civo initiative. So if you guys, if you've been using the Kubefirst CLI for a long time and you kind of raised an eyebrow at a flag here or there, a lot of the a lot of attention has been put into making sure that the Civo command is very well structured, very well documented, and we're going to continue to propagate those refactors into the AWS space and the Kubefirst local space as well. So,
and you know what? Like, if you don't already have a Civo account, or you're not sure if you want to deploy this on AWS right away, we have a Kubefirst flavor that is local. So with Docker on your computer, we make everything happen. So you can try Kubefirst, you can deploy your cluster locally, so you don't use any cloud resources. You don't have to get access at your company to try Kubefirst. So you can do it from the comfort of your computer. And because we are now in the place where we share some love, I need to show that comment from Julia, who said, "John, Jared, great demo," and I can't agree more. So I can't agree more. Good job. Those live stream are easy for me. I'm just the pretty face. You're doing all the AV lifting. So on that note, again, go check on GitHub. Go try Vault, HashiCorp Vault if you never used it, and just start to play with it. But also try Kubefirst. We are waiting for you on the Slack community. It's a pretty nice place. It's not just about Kubefirst. We're just like a couple of developer geeks, DevOps, and GitOps people sharing awesome things that are happening in the tech industry and just like trying to help each other to be successful. So, any last words? John, I know you talked a lot, but you probably have one last thing to say.
I thought I was the pretty face. I have to say, I thought I was the one with the pretty face, but whatever. It can be you today if it needs to be you.
Yeah, maybe. Yeah, I'm not going to comment on this. Jared, any last word for people listening to us?
No. Just thanks for tuning in, and hopefully if you do run into any issues, please jump in the community Slack and let us know. We'd love to help you out, and we'd love to get those fixed for everyone.
Absolutely.
And I have one last question for you. So why do submarines all use Linux? Because you can't open Windows under the water. With that terrible dev jokes, I wish everyone could. Are you laughing at the jokes, or laughing at me, or just like why Fred is doing that? Like, are you starting to regret hiring me now? Now you see the old like damage that I can do. So yeah. On that note, thanks for joining us. If you weren't a part of the live stream, but you're watching the recording, keep in mind that we're still available on Slack for you. And thanks a lot for joining, and have a good rest of the day, and hopefully being successful with Kubefirst.
See you guys.
Bye, everyone.